Hello everyone. So we are back to matrices, lecture 3. If you recall, in the last lecture we've covered types of matrices, which were 7. Then we learned few things. If you want, I'll show you. We learned diagonal matrix, zero or null matrix, identity matrix, then transpose, interchanging of rows and columns, equality of matrices, order should be same, then corresponding elements should be equal, and last thing, scalar multiplication. Time for lecture 3. Today what we'll learn is very small basic, after which we'll start with the first exercise. What we'll learn now is operations that can be performed on a matrix. Very simple operations, don't worry. The first type of operation that we'll learn is adding of two matrices, and obviously the second one, subtraction of two matrices, which are very simple. Let's take an example of a matrix A. 1, 2, 3, 4, 5, 6, whatever, 22, minus 7, 8. And there is this matrix B. If I take matrix C as 1, 2, 3, minus 4. Let's check the order here. Here the order is, for example, obviously it is 3 by 3, here it is 2 by 2. First question to you people. Can I add matrix A and C? So you might say, sir, yes, so this plus this plus this. But what with this? Do I have a corresponding element? No. So can I add A and C matrices? No. That means there is a condition to add two matrices. First condition to add two matrices is that they should have same order. What is the condition? Condition number 1 is order should be same. And what is the second condition? Second condition is addition should be done only with corresponding elements. That's it. The same two conditions will apply to subtraction. So let's take an example. If I have this matrix A and matrix B, let's take first of all, as per the first condition, same order. So A has 3 cross 3 as an order. Here it needs to be 3 cross 3. So whatever I'll take, for example, I'll take 2, 3, 4, 7, 8, 9, 0, 1, 2. Okay, doesn't matter. Now, first condition, order should be same. Yes. Second condition, adding or subtraction, whatever you're doing, should be done in corresponding elements. Means, if I write the answer of A plus B, which will obviously result into 3 by 3, the corresponding elements should be added. So the first place number with this, so it is 1 plus 2, 3, 2 plus 3, 5, 3 plus 4, 7, and so on. Minus 7 plus 1, it is minus 6. We're getting it? So on and so forth, I'll fill it and I'll get the answer of A plus B. Understandable, everyone? Nice. With these, now we can start with the exercise. The first exercise of matrices chapter. Instead of simply calling it as exercise, I'll just try and take few questions which are a variety of questions, and secondly, they might a bit confuse you at start. Okay, so I'll start with those questions. Yes, here are the questions. Just before we start, revise. If I need to add two matrices, there are two conditions, or even subtract, there are two conditions. First, what? Order should be Same. Second, only corresponding elements can be added or subtracted. Got it? Alright, and obviously the previous things that you have revised, I hope, based on which we'll start. First question. If you want, you can take a screenshot of this. First question says, if A and B are two matrices of orders 3 cross 2, 2 cross 3, that means orders are different, then their sum A plus B is possible. Say true or false. Answer is false because order is not same. Next, matrices A, which has this order, B has this order, are conformable for subtraction. That means they are confirmed that they can be subtracted. Is that true? Answer is yes, because they have the same order. And while subtraction, I'll take care that I subtract corresponding elements. Next, transpose of a 2 cross 1 matrix is a 2 cross 1 matrix. Nice question. Let's see it together. Let's take a 2 cross 1 matrix. For example, here is matrix A, which is 1, 2, 3, 4. Is it 2 cross 1 or 2 cross 2? 2 cross 2. Perfect. So can I take this? No. Let's take a 2 cross 1. So when I say 2 cross 1, how many rows? 2. How many columns? 1. So no other element. So this is 2 rows by 1 column. Let me call this as B. So here is 2 cross 1. Question says, if I take transpose of this, the result will also have the same order. If you've guessed it already, that's nice, but rest of us, let's pay attention. If I transpose this, that means I'll say B raised to T or B raised to dash. If I transpose this, row gets converted into column. So that means I must write it like this. Now tell me the order. How many rows? 1. Into how many columns? 2. So question asked whether the order of 2 cross 1 after transpose is again 2 cross 1. I'll say no. Order is 1 cross 2. So it is false. This is false. Next question. Transpose of a square matrix is a square matrix. Now think before we answer or take an example. Think. What do you think? Answer is true. If you take 2 cross 2, transpose, answer is again 2 cross 2. You can take an example. Now we'll go ahead. A column matrix has many columns and 1 row. Recall the definition. Column matrix is a matrix in which number of columns is 1 and number of rows doesn't matter. So is this one true? Answer is no, it's false. Got it? Can we go for question 2? Let's see. So it says given is this matrix is equal to this matrix. I need to find the value of x, y and z. Correct? Let's begin. First things, if two matrices are given equal, that means can I say their order should be same? Yes, their order is same. That means now I can say the corresponding elements are equal, which means x becomes equal to what? X equals to corresponding, that means 3. Similarly, y plus 2 equals to what? 1. If y plus 2 equals to 1, that means y equals to how much? 1 minus 2. Correct? Next, 3 equals to 3 obviously, and z minus 1 equals to 2. So I'll get the answer of z also. So I'll get the answer of x, y and z. Simple. Next. Further he says solve for a, b and c. If this is given, can I say same types? If you want, you can take screenshot of these questions. Going ahead. Question 4. A is so-and-so matrix, B is so-and-so matrix, find A plus B. Now addition is possible if they have the same order. What is the order of this matrix? 2 cross 1? Or is it 1 cross 2? Yes, it's 1 cross 2. So both have the order 1 cross 2. I need to add them. While adding, corresponding elements get added. So that means if I want to write the answer, you know what I'll write? I'll write here. Therefore, A plus B equals to corresponding elements. 8 plus 4, 12. Minus 3 plus minus 5. So that becomes minus 3 minus 5. That is minus 8. That's it. And similarly, I can find what? B minus A. Next question. It says if A is so-and-so, B so-and-so, C so-and-so, find, add, subtract, and so on. I'm pretty sure it's easy again. Let's see this one, A plus B minus C. So A plus B minus C, I'll say the result is 2 plus 1 minus 6. Whatever is the answer. Next element, 5 plus 4 minus 2. And I get the answer of A plus B minus C. Next. This question says, wherever possible, write each of the following as single matrix. In other words, he wants the answer as a single matrix. That's what we'll get when I add these two matrices. That becomes 1 plus minus 1. That answer comes here. Next, 2 plus minus 2. That answer comes here. And so on and so on. Correct? Next question. These are similar questions. I'll go for this one. Find x and y from the following equations. So he says this matrix minus this matrix equals to this matrix. So I need to find the value of x and y. Okay, let's get ready. So what I'll say is 5 minus 1 equals to 4. Am I right? I will write in show. It becomes 5 minus 1 equals to 4, which is already the case. Second, I'll get 2 minus x minus 1. 2 minus x minus 1 equals to 7. So can I say that I'll get the answer of x? Similarly, I can get the answer of y. Pretty simple. Same in this one. Let's go ahead. 8th one. It says, if M matrix is so and so, find its transpose. That is M raised to T. If possible, find this and this. Now first thing, I have to find iska transpose. Do you remember transpose? Convert rows into column and you're done. He says if possible find this. So if this is M, this is one matrix plus M transpose, the matrix that I found after converting rows into columns, that matrix and this matrix I have to add and get the answer. Similarly, I have to subtract and get the answer. I would leave this for you people to solve. It's easy. Going ahead. It says write the additive inverse of matrices A, B and C. Now this word only complicates, otherwise it's very simple question. Let's make it easy. Additive inverse means negative. So if A is this, what will be the additive inverse? Negative of A, that means minus A. That means answer will be minus 6 plus 5. and so on. So don't get confused with this word. You've learned this in 8th standard also. Additive inverse means negative. Next. Now A, B and C, 3 matrices are given. He says find the matrix X in each of the following. Now you gotta pay attention. Here is the first question. X plus B equals to C minus A. Now X matrix I need to find. But B matrix I can put the value here. C matrix I can put the value here. Minus A matrix I can put the value here. Am I right, everyone? Look, I've done it here. X plus B equals to C minus A. X as it is. I put the value of B, C and A. When I solve this, I'll get this. Now, can I send this on that side? Answer is yes. So that becomes X equals to minus 3, 7 as it is. Now here it was in plus, there it goes in minus 0, 2. Now when I solve this, I get the answer of X. Pretty simple. Next. Question 11. A and B matrices are given. Find the matrix X in each of the following. A plus X equals to B. So X equals to B minus A. That means this minus this, and so on for all of them. Understandable? Nice. One last type of question we'll see. It says evaluate this matrix into 3. What kind of question is this? Can I say it is scalar multiplication? That means multiplying with the real number, right? So when I multiply this, it becomes 3 into 5, that is 15 here, and here it becomes 3 into minus 2, which is minus 6. So 15 minus 6, that's my answer. Similarly here, all same. Then he says, find X and Y if this is given. I've solved it. So here is a question. 3 into so and so matrix plus 2 into so and so equals to so and so. So scalar multiplication, 3 4s are 12. 3 into X, 3X plus as it is 2Y minus 6 equals to 10 0 as it is. Now addition of 2 matrices. Yes, order is same. I can corresponding elements 12 plus 2Y. Here it is. 3X minus 6. Here it is. Equals to 10 0. I have written 10 0. Last thing, because 2 matrices are equal, now this has become, by the way, a single matrix, this thing. So if 2 matrices are equal, so corresponding elements equal. 12 plus 2Y equals to 10. So I'll get the answer when I solve this equation. 12 plus 2Y equals to 10. Can I say I'll get the answer of Y? Here it comes Y ka answer. Then 3X minus 6 is equals to 0. Whatever comes X ka answer, I get it here. That becomes the final answer of the matrix. Alright? With this, listen carefully. Now you gotta solve the first exercise from your textbook of matrices on your own. Yes, complete exercise you gotta solve. It's gonna be chindi, don't worry. Alright? With that, I'll stop. See you very soon. Thank you.